Nathan Lee performance task. Another take now that I know I'm allowed to rearrange the identity like that. So the equation we're going to be solving is cotangent theta times cos squared theta over sine squared theta minus 1 is equal to, in brackets, cos squared theta minus 1 multiplied by 1 minus cosecant squared theta. And that's over negative tan theta times cos squared theta. So the identities we'll be using are the quotient identity, which says that tan theta is equal to sine theta over cos theta, two different versions of the reciprocal trigonometric identities that say that cotangent theta is equal to cos theta over sine theta, and the cosecant theta is equal to 1 over sine theta. We'll also be using the Pythagorean identity, which says that cos squared theta plus sine squared theta is equal to 1. But by subtracting 1 from both sides and subtracting cos squared theta from both sides, we arrange this into sine squared theta minus 1 is equal to negative cos squared theta, and that's the version we'll be using. Let's get started with the left side. First, I'm going to write it out. Cotangent theta times cos squared theta is equal to sine squared theta minus 1. So I noticed two things we're going to do right away. First, we're going to take this cotangent theta and use our reciprocal identity to change it into cos squared theta, into cos theta over sine theta. And I noticed this sine squared theta minus 1, which we have right here, is equal to negative cos squared theta. So let's do that. Cos theta over sine theta times cos squared theta over negative cos squared theta. So next, we know that dividing something by something by a fraction is equal to multiplying by the inverse. So let's do that. First, we're going to combine these together. Cos theta times cos squared theta is equal to cos cubed theta over sine theta. And we're going to multiply that by the inverse of this, which is 1 over negative cos squared theta. So multiplying these together, we get negative cos cubed theta over sine theta cos squared theta. So the one last thing we're going to do is, since there's two cos thetas, in at least a cos theta squared in each of these, we're going to divide them out. So no more cos squared theta here, and we subtract 2 from this, so that just gives us 1 cos squared theta, making this side equal to cos theta, or negative cos theta over sine theta. Let's move on to the right side. So once again, we're just going to start by writing it out. Cos squared theta minus 1 multiplied by 1 minus cosecant squared theta over negative tan theta cos squared theta. So once again, what we're going to be doing first is multiplying these, is turning these reciprocal identities and quotient identities, tan theta and, oh, this is supposed to be a cosecant, oops, typo, cosecant squared theta into other forms. So this bit stays the same. Cos squared theta minus 1. This turns into 1 minus 1 over sine squared theta over negative sine theta over cos theta times cos squared theta. Cool? So next, what we're going to do is turn this into a single identity. So 1 can be equal to sine squared theta over sine squared theta. We're doing that to make the denominators equal. So sine squared theta over sine squared theta minus sine squared theta is minus 1 over sine squared theta. So, and down here we can multiply this by the numerator to give us just one simple fraction. So, well, not very simple, but you know what I mean. Cos squared theta minus 1, that'll stay the same, multiplied by sine squared theta minus 1 over sine squared theta, and that's all divided by negative sine theta cos squared theta over cos theta. So next, what we're going to do is what we did earlier, and we're going to, on this side, and we're going to take these two fractions and we're going to separate them into a multiplication equation. So before we do that, let's note that cos squared theta minus 1, we can add that to the numerator, or multiply that to the numerator up here. So what we can create is cos squared theta minus 1 times sine squared theta minus 1, and all over sine squared theta. Now we're going to multiply that by the inverse of this, or reciprocal, which is cos theta over sine theta cos squared theta. Now let's multiply these together. We'll start by adding these two. So cos squared theta sine squared theta is this. Then minus cos squared theta minus sine squared theta. Negative 1 times negative 1 plus 1. And that is all multiplied by this cos theta. And multiplying these together, sine squared theta times sine theta cos squared theta, gives us a simple sine cubed theta cos squared theta. So what we can do next that we can notice is our other Pythagorean identity again. So cos squared theta plus sine squared theta is equal to 1. So 1 minus cos squared theta minus sine squared theta is 0. So we can take this cos squared theta sine squared theta, since it's the only thing we have left in here, and multiply it by the cos theta, giving us cos cubed theta sine squared theta over what we had before, sine cubed theta cos squared theta. We factor out cos squared theta sine squared theta from each, meaning these cancel out, and gives us, oh, I forgot to mention, the negative here carries all the way through. So that gives us negative cos theta over sine theta. Now this is equal, this right side is equal to left side, so left side equals right side, and we've solved it.